We started last time with Unit 1, just kind of defining a function, really getting into that. The rest of this unit deals mainly with linear functions, so we are going to start with kind of some basic with linear functions, but things are going to be phrased quite differently than what you are used to seeing. So I'm going to try to really connect it back to how you're used to seeing and hearing things. But we're going to start using the new vocabulary and the new notation that you'll see here, okay? This lesson gets us started with what we call rate of change. You'll also see this written as average rate of change. So understand that they might use two different terms, but we're meaning the same thing here, okay? This tells us how much a function changes over an interval of time. Rate of change tells us how much a function changes over an interval of time. Specifically, we are going to be looking at the change in the function compared to the change in time. You are going to see some new notation. Some of you may have seen this in science classes before. We will be using the Greek letter delta. I am really struggling today. Greek letter delta, which looks like a triangle. Those of you that have seen this in science classes, do you remember what it means? Change, exactly. All right. Looking at how we represent average rate of change symbolically with our function notation, we can calculate average rate of change for functions given by tables, given by formulas. I'm going to ask you later, given a graph, calculate rate of change. Regardless of the representation, we're going to do the same thing. So let's say that you have a function y equals f of x on an interval from a to b. Okay, this is our interval. To find the average rate of change, we are going to take the change in our y values, which you are going to hear me call function values quite a bit. Understand that these are like output values. And we compare that to the change that's happening in our x values, okay? Specifically, we are going to take the function value f of b minus the function value f of a over the difference of b minus a. You might be thinking to yourself, I feel like I recognize this, and you might, and you should a little bit, okay? We'll get there. All right, let's look at this kind of from a geometry standpoint. I really want you guys to understand what you are finding when you find that number. So geometrically, your average rate of change quantity represents the slope of the secant line. The slope of your secant line going through the points A, f of A, and B, f of B. Now, I probably should have said this before, but you can kind of see it better in this graph. Look at your function f of x. This is not a linear function, okay? Definitely not a linear function. We have a curve. We will get next time to talking about rate of change for linear functions specifically. So we're talking about functions with curves and all sorts of crazy stuff. So when we find the average rate of change, like I said, we are finding the slope of the secant line going through these 2 points. Okay, so back to geometry class. A secant line, 2 points, right? If you think about a secant of a circle, it hits the circle twice. Okay, a secant line is hitting your curve or your graph twice. Okay, here's our secant line. We're finding the slope of that line. Oh, I did this backwards. Crap. That should be the orange dot. This should be the blue one. Between these 2 points. This first point is the A, f of A, meaning that the input value is A, the output value is f of A. I really need you guys to understand that when you see f of something, f of A, f of 2, that is output, okay? F of A is output. The point over here, this is our point B, f of B, meaning the input value is B, the output value is f of B. Questions with what we've talked about so far? Okay, one other thing before we move on. Understand that on some parts of your graph, your function might be changing quickly. So you can kind of see up here that's increasing pretty quickly. Down here, it's increasing a little bit slower. So when we're talking about average rate of change, we're kind of just evening out those variations. All right. Now, Quentin is trying to steal my thunder over here, which I do not appreciate. Is this looking familiar? It should. We've never seen it stated in this way. What are we talking about? Quentin? We're talking about slope. I've been talking about slope this entire time. Okay, look up there. Okay, so the stuff up front was from my Algebra 2 class, block 1. All the way over to the left, you see the formula to find slope, right? Y minus y over x minus x. That is exactly what this is. This is what this is. Slope. It's slope of that secant line. All right? So when you see average rate of change, you should automatically in your head be thinking, oh, That's slope. I know that. All right, so let's get to kind of a concrete example of what you're going to be asked to do. We're going to actually calculate the average rate of change for this function, just our basic parent function of the quadratic, between when x is 1 and x is 3. So in general, we're finding f of b minus f of a over b minus a. It's totally up to you what you want to think of as your a and your b. That part doesn't matter. Okay. So specific to this example, we're taking f of 3 minus f of 1 over 3 minus 1. All right, so that denominator is no problem. I can certainly subtract 3 minus 1. What about that numerator? F of 3 minus f of 1. How can I find f of 3? Kyle? No, but that's okay. Exactly. Okay, you're just plugging into your actual function. Okay, f of 3, you guys have evaluated functions in the past. So f of 3 just means that I'm taking essentially 3 squared. Yeah? Which is 9. So then what's f of 1? Ladies and gentlemen? Just 1. Because 1 squared is still 1. Then 8 over 2, our average rate of change is 4. Okay, I'm going to give you guys just a second to find an average rate of change. We're still using the same function, but your interval's changing. Okay, your interval's changing. So take a couple of minutes with your group to do that. If you are stuck, if you're kind of lost, just let me know. Still using the same function. So make sure you're always working with your table, comparing your answers. All right. So again, it does not matter kind of like what you think of as your A and your B, but we are taking f of 1, for example, minus f of negative 2. And then just make sure whatever you do first here, you're consistent on the bottom. So we should have then 1 minus a negative 2. If you went in this order, obviously it's going to be different if you went backwards. So on the bottom we have a value of 3. We already know that f of 1 is 1. Just be careful here. What is f of negative 2? So we should end up with an average rate of change here on this interval for negative 1, or of negative 1. So what you're seeing is the same function, but on 2 different intervals, you have completely different rates of change. Okay? Let's kind of look at what's happening graphically. So the first interval was from 1 to 3. So on this graph, 1, 1 is kind of right here. The scale's a little screwy. And then we went from there up to when x is 3 at 3, 9. So what you actually calculated, that number 4 that we got in the first example, again, understand that that is the slope of that line if you connect those 2 points. We would say that this interval is increasing. And then in the second example, what you guys did was you found the average rate of change from negative 2, 4 to 1, 1. I know I've repeated myself a billion times already today, but what that means you found, so that negative 1 value that you found is the slope of that line connecting those 2 points. All right, so this little segment has a slope of negative 1. My little blue segment has a slope of 4. Questions or comments? I should also add in, we would say that this interval is decreasing. Okay, which brings me to our last thing, which is talking about increasing and decreasing functions. An increasing function means that your function values, again, when I say that, I'm referring to output. When your function values increase as your input increases. Graphically, what that looks like, as your input increases, your outputs are increasing too. On the other hand, a decreasing function, our function values decrease as input increases. So each time we're looking as our input increases what the function values are doing. something like this. As you increase horizontally, your y values are decreasing. All right, I'm going to give you your tables like 90 seconds. Your job is to answer these two questions for functions A, B, C, and D, which are increasing and which are decreasing. Okay, 90 seconds. Go. Sarah, which functions are increasing? A and B, and which are decreasing? C and D. Yep. Okay. For each of these, as you increase your input values, your output values are increasing, vice versa here. Okay. Very last thing is just a little bit of notation in how we are going to describe intervals where we have increasing and decreasing portions. So if you look at that little graph that I have there for you, let's just kind of highlight or mark the portions that are increasing. So starting over to the left, and it's kind of hard to see, but there is an arrow on the end of that. So we start increasing down here, and we increase until we get to that point kind of at the top of the curve. And at that point, once we stop increasing, we decrease. And we decrease until we get kind of to the bottom of the curve. And then we start increasing one more time until we get to where the graph starts just going horizontal. So this is decreasing. This is increasing. Okay, so when you are asked to name the intervals that the function is increasing, so we have two intervals that we marked where it's increasing. Now, this, because it keeps going, where does this start increasing? Awesome, very good. Let's pretend that didn't happen. Okay. What? I am like driving the struggle bus today. I'm not even a passenger. I am just driving that bus. You will soon learn that my life is a disaster. I'm a complete disaster, but you're going to love me for it. But I usually know what I'm talking about when it comes to math. Okay. So we start increasing at negative infinity, and we continue to increase until we get to that point. And that point is when x is -3. So we describe these intervals using the input values. So what this is saying is that we are increasing for x values between negative infinity and -3. So how would we describe the other little portion of increasing? Where do we start? Okay, so 1 is less than x. Not really less than, we're just saying between until we get to 4. We can do a very similar thing for our decreasing portion. So between when x is -3 and when x is, right here at 1, our function is decreasing. And then finally, the interval where the function is doing neither is our little guy over here when we start going horizontal. That is neither increasing or decreasing. So we can say that's when x is greater than 4. Yeah. Say that one more time. Right, this portion is increasing because we're always looking at this as input is increasing. Is that, yep. Are you sure? Okay. Anything else? Okay. If you go to Canvas, I do not have any printed copies of this. If you go to Canvas, there is a color by number activity for you to do. I never ever require you to color the picture, but I do ask that as you work, you take a look at the picture page to make sure that you're getting the answers that are here so that you know you are on the right track, okay? I will tell you that there are examples where you're finding rate of change from a table, from a graph. I know that we did not necessarily do examples like that. This is where it's up to you guys, and I'll be here to help you, but it's up to you guys to really think through this and apply what we talked about, okay? You have the rest of time in class today to get a start on that and maybe finish it, depending on how you're doing. Okay, so I'll be around if you have questions. Please feel free to work with your groups. Okay, so remember we're taking basically difference in your output over difference in your input. Okay, so this is the interval they're giving you. So these are the input values they want you to use. Okay, so using this table, so basically what we're doing is f of 10 minus f of 0 over 10 minus 0, right?
Okay.
How do I find these values? So how do I find, using this table, f of 10? Exactly. Okay. F of 0 is? Okay. Yeah?
Yeah, I was just a bit confused.
Yeah, I know. It's kind of...
speed.
Yeah, same thing. Average speed, average rate of change. You're going to see all sorts of kind of phrases like that. Okay? All right, guys, so, I mean, this happens every year. It's not just you guys. We found output values together when we were given the function. So, like I said, you are given a couple of tables, you're given a graph. You're still doing the same thing. You're just going to have to find those output values in a little bit different way. So, see if that helps. If not, just let me know. No, I mean, what problem is this?
Yeah, so that means 140 is 10, right?
Oh, I'm number 1. Forgive me. Yep.
when you like you set it up for you, right? It's the A and B value thing. Your A value is your A value is 0, your B value is 10. Well, at least the way I set it up, right? So that means you also put it down under there. So that means 10. B value is 10, so it's 10 minus 0. F B minus F of A, and then over it it's B minus A. But then when you find this function, that becomes 140. Because F of 10 equals 140, right? And that's minus 0, so it stays 140. And the 10 minus 0 is 10. It's going to be 14. Because, right, yeah, because okay,
Because we're having
because these are functions.
Remember in this one, so because you can't just subtract the 3 and 1, you had to plug back in to get the values for it, and then so that's the value for is for you like the it's in the table, you plug the output back in. We just got the answer, so we don't need to type here.
Nothing at all.